Hello again to you, my dear friends and companions. Thank you for being with me in the sixth video of the Python programming training series. In the second chapter of Python programming, we will examine the data structure. As we said earlier, data structures are data storage spaces. We know that in today's world, all activities are done with data. For example, we can refer to decision making in medical and commercial fields. Today, all these decisions are made based on data. In general, the main use of programming skills in today's world is its use in data science. In fact, these data must be processed with the help of programming languages. To process the data, you must first keep this data in spaces. These spaces are called data structures. The types of data structures are list, set, dictionary, and tuple. We will talk about these in detail and explain their features in detail. Before continuing the discussion, let me explain about one of the most powerful tools in Python programming. You can Google the word Anaconda and OK. You can see that here there is an explanation about it. Anaconda is a distribution of the Python and the R programming languages for scientific computing that aims to simplify package management and deployment. The distribution includes data science packages suitable for Windows, Linux, and Macs, and etc. Okay. In fact, there are many facilities including IDEs and also many modules inside Anaconda. There are a number of modules in Python by default, and you can use them when necessary. A bunch of other modules can be installed. That is, they are not installed by default in Python, but you can install them yourself. We will explain how to install these modules later. Anaconda has many of these modules inside itself. That is, you do not need to install these. We will work with the Python part of Anaconda and not with the R part. You can use many of the required facilities, especially in the discussion of scientific calculations which are not available in Python by default without having to install them. So you can enter the Anaconda site. Considering that it is free, you can easily choose and download the version suitable for your system. Due to the large size of Anaconda, it may take a long time to download depending on your internet speed. Okay. Since I have already downloaded Anaconda, I do not need to download it again here. The downloading and installing process, of course, has nothing new and special. Just open and run the exe file and do not change any settings. Okay. So here we want to back to the Python environment actually. Here we need to point out some small points. Let's talk a little about data structures in Python. We want to dump the data somewhere and work with it. If we have only one data, the task is very simple. As you saw in the previous video, we had a wait time variable into which we put the output of random.randint in the range of 1 and 60, if you can remember it. Actually, say let's do it here. We should first import the random module and then create the variable again here. Okay. Random dot random in the range of 1 and 60. Okay. After pressing enter, we do not see any result because this line of code has no visible result and is just an assignment. By calling this variable, okay, we will see the visible result. This 10 number is a random integer number in the range of 1 and 60. As we said before during this assignment, the variable type and its value become the same. We are generally talking about objects here. As you can see, the word object is seen a lot here. In Python, everything is an object. A direct result is that you can assign all objects to variables. This sentence, which said everything is objects in Python, has an interesting result. In Python, we can dynamically assign an object to any variable. All data values are inside Python objects. In Python, like other programming languages, objects can have states and behavior. States which are the values and attributes, and they can have a series of methods. In general, if we want to look at this case with a general view, objects come from classes. What does class mean? For now, I want to give an example. I don't want to get into the programming discussion about classes yet. In the chapter related to classes, I will explain in detail the concept of class in programming. Here, suppose you have a class called the car class. In the car class, we have a series of states. For example, you put different parameters in this machine next to each other, like color, tools, pedal, gear, steering wheel, tires. Now, this class has a series of methods. That means, for example, you can press your foot on the gas pedal so that the car accelerates. You can press the brake to stop this car. You can pull the door handle to open the door, or many other things. Or for example, consider a humanoid robot. You put a running method for this robot, you leave a walking method, you embed a handshake method that can, for example, shake hands with you. You can embed the talking method in this robot and many other methods. Methods are tasks that instances of a class can do. These instances of each class are the same object. For example, a robot A is an object that is a member of the robot class. Here we just wanted to have a short introduction of class and object. In programming, we have a discussion called the object-oriented programming. For example, Java forces you to program object-orientedly. Is Python the same? Does that mean we have to program object-orientedly in Python? The answer is relatively. Means that to some extent. It means that you can program in Python object-orientedly and you don't program in Python object-orientedly. You can work with classes, objects, and methods, but you don't have to. As we have not directly used any method so far, so know that in Python everything is an object obtained from a class as a source. In this way, it can be said that Python is not object-oriented, but object-based. So far, we have talked about saving a data. Now, if we want to store a set of data, considering that we are faced with big data today, there are many uses of spaces for storing a set of data. As we said earlier, there are 4 types of basic data structures for this purpose. The first one is the list. The lists are regular and can be changed. They have indexes. Lists are dynamic in Python. That is, according to your wishes, they can be enlarged, reduced, changed, and various tasks can be applied to them. The lists are heterogeneous, that is, they can contain different types of data types. Another type of data structure in Python is the tuple. It is regular but cannot be changed. It has the properties of a list but is immutable. That is, look at the tuple as a static list. The question may arise for you, why should you use a tuple? Well, let's use the same list but don't change it. The answer is that sometimes, in some cases, this immutability becomes important. In some cases, order is not important. For example, if we want to keep the ID and password of a number of users, there is no need for order. In these cases, we use dictionaries. A dictionary is a collection consisting of a number of key value pairs. This set is irregular. Dictionaries changes are also acceptable. In fact, the dictionary can be seen as a multi-line and two-column data structure. Another data structure called set is available. It is used in situations where you want to remove repetitions. And just like mathematical sets, they follow the rules of community and sharing. These sets are unordered, mutable data structures that contain unique objects. These four types of data structures are very useful. Now we will examine each one in detail. Okay, let's enter the tool Anaconda, which is a very useful. Let's open the Anaconda Navigator. You know, it always takes a long time to run the Anaconda, because the Anaconda is very huge. Its size is very huge, and so it takes time to run on your system. Okay, when Anaconda Navigator is opened, you will see different programming environments in Python and R languages. Among these, we choose Spider. There is also the ability to change the background color, and we will see that. You see that the Anaconda Navigator here is initializing. We will check all of the Spider's options together. Okay, just wait a few minutes more to load the Anaconda Navigator. Pay attention that to start learning programming in Python, the best way is to work first with Python itself, then with Spider in among Anaconda's options, and then enter JupyterLab and Jupyter Notebook. Note that the colors of expressions and keywords are different in Python and Spiders, which we are going to see them together. Okay, here this is the Spider, and this is JupyterLab, this is Jupyter Notebook, and there are some R programming environments here available, but we do not want them. You know, they are not in our scope of working. Here we launch the Spider. Okay, as I said before, there is also the ability to change the background color. The spider will open in few minutes. You can see the powerful environment of spider, which is very similar to the default environment of Python itself. As I said before, the color changes of expressions and the keywords of Python and Spider a little are different, but Spider environment and Python environment are very similar to each other. You can see. Okay. Typically, the anaconda is not such slow. This slowness is because of my system's problems. Do not be worried about this slowness. On your system, it will not take such a long time. Do not be worried. Okay. Now the wall of spider. You can select the preferences option from the tools tab. Here, that is the tools tab. Okay, and this is the preferences option. And change the settings. You can change keyboard shortcuts. You can change the colors from the coloring syntax section. I myself prefer Spider Dark actually. Here, these are the options. Okay. This is the keyboard shortcuts. There are several options that you can try. Okay. Actually, these are not such important. I myself prefer the default settings always, but you can change the font and size here. You can change the colors here, syntax highlighting theme actually. You can change any. I do not want to do that always, you know. Okay, let's press the cancel. Okay, let me close this part. Let me close. Let me okay, I'm going to close this too. Okay, this is yeah. Okay, here that part of the screen is as same as the script mode, and the right part here is as same as the script is as same as excuse me, the Python shell in the upper right part here. There are variables with the types which are sometimes very effective in debugging. This kernel which is actually as same as the Python shell. In comparison with Python shell itself has the ability to scroll. It can be restarted. The option of restart is here, and it would be active if there is a dirty console. Actually, it can be restarted and has better features than Python shell. You can also open a new IPython console here. We call it IPython console actually. Okay, you can open a new one like this. Okay. Let's do something. For example, let's define a variable equal to, for example, 5. A b variable equal to, for example, hello. Excuse me, hello. Here, if we press the F5 key after coding in the left section instead of escape mode, we will automatically enter the section of saving the program. We can see it. We press the F5. Oh. Excuse me. Okay, you see that here in Spyter we do not need to save each item, and the saving process will automatically be done. Okay, we started working with lists in Spyter. How are the lists in Python? Excuse me. Let's do that for here. Okay. How are the lists in Python? The values in a list must be enclosed into square brackets. As you can see, by defining the variable a is equal to 159. Actually, here, let's do it. Let's restart this IPython console. Okay, let me do it here. Okay, you understand it. Okay, here the variable container part. Let's restart this kernel. Yes. Let's remove the defined variables. The variables are removing, and let's have a new project here. Okay. The process of removing the variables are progressing. Yes. Okay. And now let's define the a variable as open a square bracket, insert a 1 number, insert a comma. It is better to consider a space. Insert, for example, a 5 number, insert another comma, and it is better if you consider another space, and insert, for example, a 9 number. you have to close the square bracket. Okay. Now the summary information of this variable was placed in the upper right part. Let's go back to the previous program. Here you have it. Okay. Here if we copy paste it, you can see that. Okay. Here, this is the lateral odds list. We call it lateral list because first it is fully defined and then we worked with its values. Lists can also be defined at the beginning and we can add values to it over time as we progress in the execution of the program. So there is two ways of list creation. Lists can okay. As we said before, lists can consist of strings and numbers. I can show you various examples here. This can even contain other lists. Let's try them. You here can see a list containing just numbers. You can see another list containing strings, for example. You also can see define a list like, for example, sum of its members as integer and the sum of them as strings, for example. Or you can define lists like this, for example. You can, a list can include another list in it. These internal and nested lists can be heterogeneous too. Something like that. Okay, now let's do a project to understand more. Okay, let's restart the kernel again. Okay, remove the variables again. Yes. What is the project? Determine a word and determine the number of vowels. To do this, we define a variable v as a list of 5 English vowels. Then we define a string variable w equal to, for example, a string like inside. In fact, this is the same word that we want to determine the number of vowels of it. Okay, let's do this. For example, define a variable v as a list of 5 English vowels. So what are the 5 English vowels? A, E, I, O, U, for example. You can have, we got an error because we forgot to put these vowels in the quotation marks because we have to consider them as strings, so we need to define the variable again, and this time put the vowels in the quotation mark. Okay, you can see that here there is no error. And after that, we want to define a string variable like w, which is equal to, for example, insight. Okay. To do this project, we need a repeating loop. Here must also use an if condition. That is, we say that for every letter that is inside W, if that letter is also inside, we print it. Okay, remember what we have said about the for loops and the methods of its usage. We can say that for letter in W, okay, W, of course it must be capital. If letter in V, okay, so print it. Print this letter, okay. Okay, we can see the variables here, and you can see that the results are printed here. There are two I letters here, which are two vowels of the word inside. Okay. That is, in this way, the letters of W are compared with the members of the list V one by one. In this part of the IPython console, if we press the upper arrow of the keyboard, we can access the last code we wrote. Let's try it. Oh, yes, yes. We want to improve this program a bit, so we move it to the left. Let's move it to the left. We can use the copy paste method, but here, when you are copy pasting, be aware of these dots. Oh, okay. We have to okay. When copying and pasting, pay attention to the three dots on the side so as not to get error. If you are in Python and Python shell, the side arrows will be copied and pasted, which you should be aware of. And note that all the variables are stored in the upper right part, and if you don't want to use them, you must delete them, which we have done it previously. If we want this program not to show us the repeated vowels, we have to use the super abilities of data structure set. But for now, here we choose another way. Suppose we create an empty found list. If we apply the length function to it, we will see that its length is 0. Lists have a wonderful feature called append, which can be used to add members to lists. I can give you some examples here. Let's do it first on this IPython console. Okay, here we can have a list called found, which is an empty list. You can see the found variable, its type is list and its size is 0. We can apply the length function on it, and you can see that the output is 0 because its length is 0. Okay. We talked about the append option in the lists discussion. We can use it here, found.append. For example, 1. Yeah. Now let's see what is the list found includes. You can see the one number. So this line of code added this entry, which is the one number, to this empty list found. We can, for example, try found.append a string this time, for example, hello. If we call the found list, you can see that it includes the one number which we previously added to it by the append method, and the hello string which we recently added to the found list by the method append here. Okay. Please pay attention that the variables which we defined here in IPython console will be not be defined here, and if we want to use them here, we have to use them again. We can actually remove this found variable for now and then define it here. Let's define an empty list which is found. Okay. Now what do we want to do? We want to do this. If there was a vowel in found, we don't want to add it. But if that letter was not in found, add that letter to the found list. It is clear that we need help from in for this purpose. The absence of an object in a list can be checked with not in operator. We use the conditional loop if and say that if this letter is not found in this list, add this letter to found. Let's say that for letter in W, if a letter not in, no, for letter in W, if this letter in V, and if this letter not in found, Chicago, not in found, add it to found. Add this letter to found. Okay, so we should set found dot append this letter. Okay, and after that we need another for loop for vowel in found print that vowel. Okay, so this NOT-IN operator is also very much powerful. So in the heart of this project we also learned append and NOT-IN, and to run the program we say we didn't use this new option to start a new project. Let's press the F5. Okay, and we can see here that the variable found, which its type is list, now its size became 1, not 0, and it includes I. And you can see that the number of the I vowel in this list is just 1. So as we wanted, we could prevent the repetition here. Actually, we must first define the empty found list, because if the found list is not defined, what list should the vowels be added to? Now in the last iteration loop, we tell it to print the vowels inside found. You can see that this vowel is printed here. Pay attention that, okay, I talked about this before. If we want to talk a little about the functions in Python, we can mention input. You can use input and want users to enter a word here. For example, you can here you can comment this line and use the input function to have this. Let me do that. We can comment this line and define a value as an output and result of the input function. We can write enter a word, for example. Let me say it. Maybe the input is with, okay. As you can see, the Spyder environment is sensitive to the capital and small letters. Now if we press F5, we can see that as an output of the program, we see the phrase enter a word, and we can here type a word. For example, let's type Python, and we can see the output here. This is the printed vowel, the printed vowel of our entry word, because we entered a Python word and its only vowel was the O letter, so this letter was printed here. Let's run the program again. This time we want to write more longer phrase. For example, hello, how are you? You can see that the printed vowels are more because the available vowels in the entry phrase was more. You can see these here. Okay. We can use a remove to delete the value inside a list, and this deleted variable is never available to us if we use the remove option. But if we have the index of that value inside that list, we can use a pop, in which case we can access that value. If we don't give the index number to pop, it will return the last member of the list. The method of using a remove and pop is to use the name of the list and to insert a pointer and then write the word remove or pop itself. These two each have inputs. The removes entry is the value we want to remove from the list, and the pops entry is the index of that value in the list. And in addition to removing that value from the list, that value itself is also available to us. You can try different examples. Here, let's try them with each other. We can restart the kernel in order to become empty and neat. I want to remove the variables here too. After finishing the process of removing all variables and restarting the kernel, we will see some examples about the usages of remove and pop methods and their applications in the lists. Let's define a list. For example, A is equal to, for example, A, B, C, D, E, F, and for example G. It is enough. Okay. Now let's apply the remove method on this list. We should insert the list name, which is A here. We should insert a dot or a point here, and we should write the method's name. We want to use the method remove. As we said, remove and pop both have an entry. The entry of remove is the value itself. For example, suppose that we want to remove this value, the B letter, from this list. So we do it. Now we can call the A list, and you can see that there is no the B string here because it was deleted. We deleted the B from the list A, but we cannot access this value. But for example, if we use the pop method, which is as same as before, we should insert the list name, which is A here, insert a dot, and insert write the method's name, which is pop. This method is also gets an input or entry, but this is the index of the value here. For example, because as you can see here, the explanations are available. For example, let's enter the index, for example, 2. As you can see, the A list is here. Their indexes are, the index 0 is for the A string, the first member. The index 1 is for C string, the second member, and the index 2 is for string D, which is the third member of the list. So we can press enter and see the result. You can call the A list again, and you can see that there is no D string in A list, and this member become deleted from this list, and you can see that the pop method returned this value to us. Okay, you can yourself try another examples. Thank you for being with me in the sixth educational video of this series. I hope that I have been able to provide you with a